Hi, boys and girls. Welcome back to Mr. Cedarbach's geometry class. Here's what we were working on today. So go ahead and open up your ebook to this lesson. Feel free to pause the video if you need some time to get there. And don't forget to take out your pencil and paper and write down today's lesson target. Feel free to pause the video if you need a second to get those out and to copy it down. What, you think it's weird to wear a bike helmet with a shirt and tie? Whatever. Let's get started. Lesson 7.2.5, how else can I write it? Two-column proofs. I'm going to read today's lesson introduction. Today you will continue to work with constructing a convincing argument, otherwise known as writing a proof. In this lesson, you will use what you know about flowchart proofs to write a convincing argument using another format called a two-column proof. Now, while this lesson has some really good problems, we're actually not going to do them exactly as they are. We're going to simplify it a lot. I'd like you to take out problem 7-82 from the previous lesson. It looks something like this. So either turn there if you have more room to write around this problem, or if you want to copy that flowchart onto a new page where you have some room to write some additional things. So what we're going to do with this is we're going to take this flowchart and we're going to rewrite the exact same argument, but just in a different format called a two-column proof. So first, title this as what it is, a flowchart. And then somewhere nearby, write the title, two-column proof. Again, a two-column proof is just another way to write the same thing. It's the same as a flowchart. It's just different organization. So we create a simple T-chart that gives us our two columns. On the left-hand side, we write statements. And reasons on the right. I like to number each statement and reason because it helps us keep track of which goes with which when the two-column proof starts to get long. So what is our first statement? Well, if we look here, the topmost statement we made was that ABCD is a rectangle. And so I'm just going to take that and I'm going to copy it right here. And then what was our reason for being able to make that statement? Why is that true? Well, it was given to us. So I copy that and paste it. Statement 2. If ABCD is a rectangle, then we were able to say that angle D was congruent to angle C. Why were we able to say that? Well, because of the definition of a rectangle. Statement 3. Now, if at this point you feel like you can go ahead and finish this on your own, try and do it. Maybe hit pause and then go through the video quickly after you've given it a try. If not, feel free to keep watching until you see how to do it. AD is congruent to BC is our next statement. Why? Well, because opposite sides of a rectangle are congruent. Now, what if at this time I put this statement here? I put this as my fourth statement. The problem with that is that above this, somewhere up here, above it, I need to have all of the conditions for this. All of the ifs. And right now, I only have these two. And so I would have to have that third condition, this one right here, above it in the 2-column proof before I can write that triangle congruence statement. So I'll just write this one, DC is congruent to DC. And now I can write my triangle congruence statement. And there is the argument for this problem written as a 2-column proof.